through a variety of other modules that we've talked about networking in very specific pieces, whether it be the IP addresses, whether it be through some kind of routing capabilities or load balancing. All of them need to be monitored and troubleshot. And so there's a tool belt of skills that you needed to have to be able to do that in a traditional network. Now, those skills are still needed, but we have specific requirements inside of Azure because you don't have access to the wire like you had in the past. Your ability to actually have physical access and complete control of the network wire communications is not going to be available to you in Azure. So what we have is a specific tool set that is going to make the traditional information available to you to do that job. My name is Bob Tickleman. I'm excited to be your guide for this module. Now let's get into it. As I said at the introduction, the skills that are needed to make sure communication is happening between two endpoints. There might be multiple hops between those endpoints, and how do you determine what's broken? Is it, out of your machine? Is it able to get onto the wire? Does it get to your local gateway? As you go to a network provider or an internet provider, is it them that's breaking it down? Is the problem at the far end? All of this information, looking at packets going through the wire, are all skills that are required. In the past, you might have had a set of tools that you use, things like Wireshark, to be able to install on a device that you could then monitor all the traffic that's going through a wire. We don't have access to that information. So what Microsoft has made available to you is a specific toolkit of tools. We're going to take a look at Network Watcher as an oversight tool that has several components inside of it that will give you the fine-grained troubleshooting and information that you're going to need to diagnose and look at your wire traffics in a traditional manner. So as I said, Network Watcher as a tool belt of tools is made up of a whole set of components. We have connection monitors, we've got NSG diagnostics, we have effective rules. So if you go back to the recording when we talked about NSGs, or the network security groups, we saw that there was a set of rules that you could have that would be processed. We saw that NSGs could be applied at several levels. You might have an NSG on the inbound of a subnet. You might have an NSG at the inbound of a network card. You have that same NSG for an outbound of the network card and an NSG that is on the outbound for the subnet. So you have 4 potential places to block any inbound or outbound traffic. Well, where that's going to come through? Well, we have capabilities to now take a look at the NSGs, the ones that are in place, because there might be multiple along the way. And then what we have is multiple rules, and we've got to figure out what is the effective rule we're dealing with. So there is a tool that you have using Network Watcher to be able to do some of this. Some of you might be familiar with tools like ping and path ping, traceroute, to be able to figure out, can I communicate between two endpoints? IP flow verify, we have the capabilities with NextHop. These features combined together give you capabilities that replicate some of those traditional ping and path ping commands, traceroute, that you would use in a traditional network environment. Now, you still might be able to do some of them, but you might not get the level of information because you don't have access to the wires and all of the steps that are in place. So this is going to be the tool that you're going to want to leverage to be able to get that deep level of information to be able to diagnose where troubles are. So taking a look through these tools specifically, in addition to Network Watcher, on the blades, and we've done this a number of times in other modules, where we showed you on the blade, there might be some overview settings. There was the IAM, or the Identity Access Management, or Access Control, or RBAC, which we use the term for. There was activity logs, there was settings. One of the options down that left-hand blade side was there's one in there for review monitoring tools. And so you have one that will allow you to actually go in and take a look at the architectural design of all the components and how they're connecting. And so you have a topology map. We have the connection monitor. So when you create a VNet peer, if you wanted to test to make sure it was working, where you might typically go and put a device or have a device on one VNet and try and ping the other device, you can actually do that from the graphical interface using the connection monitor and identify where the potential break in communications might be. The flow logs are going to be able to give you a history of the activities, because while you might have a specific point in time issue, things like pinging and checking the flow. Well, I know it's not working, but when did it stop working? And you might want to go back to a point in time. And so the flow logs are going to provide some historical information that you have available to you to be able to see information over a period of time. We also have some analytical information about traffic analysis. So it can aggregate the NSG and the VNet flow logs so that you can now drill through on some of these reports to be able to potentially identify when did the problem start, what might have happened around that to cause that issue to be the problem that you're now trying to troubleshoot. I mentioned that we had traditional tools like Wireshark that allowed you to actually capture packets, and it was a piece of software that you typically put on a device that was connected to a network segment, and all traffic would flow through it and it would be able to actually capture those packets. You don't have access to the wire. So let me just do a quick whiteboard to explain what it is that packet capture is going to allow for you that you wouldn't be able to do because of the type of networking we have in Azure. Inside of a traditional network, if you had a device that had something like Wireshark on it, you could actually be listening to, my bad drawing of an ear, you could be listening to all the packets that are going across this network segment, whether it be, these are subnets. It could hear all the traffic that's coming across this environment. When you get into an Azure VNet in this case, the actual wire in which the communication happens between these resources is not physically available for you to define or work on. I have a blue user doing something. In the physical wire, you have your own specific set of communications that you and only you have access to. If I have another user, green user, that was using something for their VMs that they have and maybe their storage accounts, they might be using the same wire, but in the software-defined world, it is a secure component that is unique to them. So you can't have a device that is going to be able to listen to all the activity on the wire. So what you're going to use with Network Watcher and this packet capture, it is a service that Microsoft makes available to you because we get to see all the packets going through, and we're able to surface up just the packets that are in your secure network that you're working with. So you can still get the information, just that you can't get it from a traditional manner. So packet capture, a great way to work with this. IP flow verify for me becomes that verification. It's that traditional ping that you might do. I'm going to make sure, can I verify that I can get from one endpoint to another? And Network Watcher is going to provide that inbound, outbound traffic and tell you where that traffic was failing. We saw this in a previous module we recorded. There's a connection troubleshooting that will go through a diagnostics. It goes and takes a look at several different issues. Is it a DNS issue? So it's more of a broad stroke tool to determine, is it a physical network communication? Is it unable to resolve the address based around a DNS failure? So connection troubleshooting breaks down a series of activities that might be used in a communication and reports back on the discrete components that make up the overall network communication components and identifies where the breakdown might be. Similar to the flow verify, next hop is going to help us determine, this is more like the path ping or the trace route, where I need to understand the specific hops that might take place between, if I just did a ping command, and trying to hit this device, and is it on the return? Is it on the outbound? All you get is device unknown, or it's not able to connect. But there may be several stops along the way. Maybe you've got some routers that are along the way. I want to find out, where does that communication stop? So it shows you all the hops along the way. So Next Hop is a great tool that will do that and show you where the communication is being dropped. We see that there's more tools in the tool belt. I'm going to go to the VPN troubleshooting. With the virtual private network, we haven't covered that module at all. You take a look not just at the physical communications, there's a whole set of protocols and handshakes and authentication that have to take place. And so again, very much like we saw from the troubleshooting method, there's a series of components that have to be combined together to effectively make sure that the communication infrastructure is being built. As I said, you need to have a tunneling protocol. There's got to be authentication that goes through. You got to make sure that at the other end of the tunnel that you're working on a common protocol for that. Is it PPTP? You know, all of these pieces have to come together. So all of these different tools will allow you to then collectively be able to manage all of the network communication troubleshooting that you'll need to bring to bear to your overall solution. As well as the VM network troubleshooting, this is going to get back to more of the VM side as opposed to the Azure networking services. So far, we've been taking a look at VNets and subnets and application gateways and NSGs. Within the virtual machine itself, there's a whole set of troubleshooting that you may need to get from the virtual machine that has a virtual network card inside of it that then communicates with the Azure networking services. We've talked about the NSGs a couple of times, so we want to take a look at what the effective rules are going to be. So I've talked about in the NSG module, you have an inbound rule at the subnet level, you have an inbound rule at the network card level, you have an outbound rule at the card, and you have an outbound at the subnet. So any combination of a deny or not being able to communicate through is going to be a potential block. Where's that happening? So the NSG effective rules is going to show you the rules that apply, the ones that are going to be the ones that got through here, you got through here. It's the outbound on the network card that is going to be the problem that you're working with. So getting in and taking a look at this, these are going to be the tools that allow you to get more effective into the NSG and its processing it's doing internally. So that is an introduction to a broad range of tools that replace the traditional tools that you might have had in your arsenal to bring to bear on your network troubleshooting. A single tool with Network Watcher provides all of the capabilities in one location in a manner that you can now gain access to the traditional troubleshooting information that you need without having to have the tools because they won't have access to the actual infrastructure that you would have had in the past. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.